for joining us today. We are about to dive into our Thought Leader Series webinar, using IoT monitoring tools to optimize and protect cannabis crops. I am your host, Taryn Picard. I am the Global Product Marketing Manager here at Onset. I have been working at Onset for just about 10 years now, and I absolutely love HOBO data loggers. So just to cover a little bit of our webinar details with you today, this webinar will run for approximately 45 minutes, and we will save some time at the end to answer questions you may have. Feel free to go ahead and type those questions in to the panel over on the right-hand side of your screen as we're going through the webinar. If it's something specific to our data loggers, I'll do the best I can to answer it for you. And if it's a question for our presenter, I'll be sure to read those off towards the end. This webinar is being recorded, and a link will be sent to you in a follow-up email after the webinar. So just real quickly, let me tell you a little bit about who we are and what we do at Onset. We make the HOBO data loggers. We are located on Cape Cod, and we have been focusing on making accurate and reliable products for monitoring for about over 40 years now. And we are a global distribution network. Our products are sold all over the world. And most importantly, we are super focused on lean manufacturing and being ISO certified. So we're making sure we're making the best quality products the most efficiently for our customers. So now to dive into today's presenter, I have the pleasure of introducing Nathan Ortiz, who is the owner of High Standards Consulting. After receiving his bachelor's degree in tropical plant and soil science, Nathan moved on and started working into the cannabis industry in Hawaii, and then moved out to Colorado, where he was part of a research and development team tasked with improving product quality and increasing production levels for indoor, outdoor, and greenhouse grow facilities across multiple states and in Canada. And currently he is writing the curriculum for a new Bachelor of Applied Science in Cannabis Science and Operations at the Community College of Denver. So with that, Nathan, let me hand the floor over to you.
Thank you very much, Taryn, and thank you all for being here. Today, we're going to talk about using IoT monitoring tools to optimize and protect cannabis crops. This system is today's focus. This is the HOBO MX2301A and the MX Gateway. This temperature and relative humidity data logger is tough. They're rated for outdoors, so they're strong enough for the indoor cannabis space, which can be hazardous to electronics. The logger is NEMA 6 and IP67 rated. And the Gateway allows for live dashboards and alarm notifications. I've had really great success working with the system for about the last 4 years. Optimal ranges, this is why we're here. In regards to temperature and humidity, apart from other variables, indoor commercial cannabis has a range for optimal growth and a range for microbial safety. Outside of this range, the risk increases for poor production and plant health issues, as well as an increased risk of microbial testing failure. And this is why environmental monitoring is so important. When the data is collected and presented in a digestible format, preventative steps and mitigation can be taken. In general, warmer, humid air facilitates microbial growth, and microclimates can assist areas to drift outside of the optimal ranges. The optimal ranges themselves vary based on a number of factors, but by collecting the data and having multiple pathways of utilizing the data, the specific ranges can be researched and optimized. I've done a lot of research using these loggers, and I'm happy to share with you all today some of the things that I've learned along the way. All right, so today we're going to get into sensor placement, mounting, and distribution. We're going to talk about displaying the data via dashboard. We're going to get into configuring alarms and notifications, and we're going to finish up with backup safety monitoring. Now, the quantity and type of variables from microclimates depend on facility design. The microclimates can come, from a variety of sources. Do you have a single section per room, or do you have one large room made up of multiple sections? What kind of lights do you have? How many? What is the distance from the top of the canopy? What is your heating and cooling system? Where are those vent locations? Do you have supplemental HAF fans? How many? Where are they at? Are you working with rolling benches with full width flood trays or multiple narrow flood trays that allow more airflow? Are you doing a single tier of plants, or are you doing a multi-tier racking system? This is just a few of the variables for microclimates, but it all depends on your facility and facility design. So what is the info we want? Like what do we actually want to measure? Because what we want affects where we want to sample the data. And so for cannabis, it's the plant's environment, and particularly the flower's environment. Are the plants okay? Every operation manager I've met wonders how their plants are doing when they're not around. I personally love the experience of supplying them with a dashboard and notifications and actually relieving them of some of that anxiety. The accurate collection of data is equally important as its visualization and communication with its user audience. All right, let's get into sensor placement and mounting. So where do we put it? What we figured out is the best, most accurate, the ideal, the most useful data is if we sample at the top of the canopy. And that is anywhere from the top layer of trellis to the top of the tallest flower. It needs adjustment over time, but it gives the most accurate reading of the plant's growing environment because it has the greatest interaction with lights and air. So some common less than ideal placement locations, such as in front of a fan or duct, mounted too high or mounted to a pipe or an external wall. I've seen a bunch of environmental sensors in really interesting locations. Like the question is what are you actually measuring? That external wall could get really cold in winter. So although the sensor is accurately reporting data, it's not as useful as it would be if you were sampling at canopy height. So trellis poles are another common attachment location, but I've had issues with them getting accidentally sprayed with, organic soaps and oils by IPM technicians. It's not always giving the most beneficial data. I don't recommend it, but there was a client whose IPM team mistakenly sprayed their loggers on a schedule for a year. I compared the readings against new loggers, and the sprayed loggers were still accurate. And that's why these sensors are tough. But yeah, attached to trellis posts, right, is not necessarily the best location for these loggers, because also the plants tend to envelop the trellis posts, as you can see here. And so, the data, again, is still accurate, but it's not necessarily as beneficial as it could be. So where do you place and where do you mount the loggers? Honestly, the tomato yo-yos were the solution. They're spring tension height adjustable. I basically flipped them upside down and attached the mechanism to the logger, and then attached it to a chain that's hanging down to about light height, because they're only so long, but they are pretty long. Usually the lights are centered and there's a bar over each rolling bench, and so it just works to drop it down right there. Amazon has them for less than $1 to $2 each, so it's really affordable. Highly recommend it. It allows for easy adjustments to canopy height over time. You're dropping a new layer of trellis, you just raise it up. Loading new plants, raise it up. There's it's easy to locate to bag, or to just raise it up to move out of way for IPM pesticide applications. Also, if you just drop the logger and catch the bottom of it into the center square of the top layer of trellis, it often stays with the rolling bench as it moves from side to side, which is nice. All right, let's get into sensor distribution now that we know where it's best to place and mount them. So what we found out is that there is a minimum of 2 loggers per section, is really what it is. With microclimates, a single data point did not give a full account of plant conditions. 2D grid pattern for single tier rolling benches like this picture, or a 3D grid pattern for multi-tier plant racking systems. Basically, you just want to get every section and kind of cover your bases as much as possible to get an average reading that is accurate. But at least 2 data points distributed per section is necessary. Section design and layouts vary, but spend the time investigating each section. Is the back corner getting more humid? Let's try to fix that, or at least monitor it. When the data is collected well and displayed and communicated effectively, it becomes a very valuable tool. If you have multiple facilities, I highly recommend creating a standardized naming convention. A 6-digit or 9-digit system works really well. The goal is just to create a system so that the physical location of a specific sensor can be determined at a glance. Make it easy. One or two extra loggers for investigative purpose is a good practice. Site-specific areas, verification of equipment. Do you have a localized plant health issue? Just process of elimination. Stick a logger next to it to investigate if it's temp or RH related. You have a question about a particular piece of equipment, put a logger next to it, verify its performance. There was a client who had a humidifier in their dry room. I stuck a logger next to it and quickly discovered that the humidifier was malfunctioning in the middle of the night, which is not good. So that was a nice catch. Just having a few extra loggers around is a good idea, especially as a comparison against deployed loggers. An outside sensor can be a valuable tool for on-site facilities' specific weather conditions. You can use it as an event trigger. Stick a logger outside. Measure what the facility is being exposed to. Again, these are rated for outdoor use. Not all your equipment runs at peak performance during extreme weather. Find out what your facility specific threshold is in order to be more prepared for the future to mitigate facility equipment and plant stress during extreme weather. All right, let's talk about displaying the data via dashboard. I know a lot of you may already be using Onset products, but I wanted to highlight the HOBO website dashboard builder page. There are many customizable widgets and settings with multiple display options. It's easy to create user-specific dashboards that display the data in a way the user can understand and utilize. From polling managers, the most common widgets requested were the custom line chart widget and occasionally the latest conditions widget. Here's the custom line graph widget. I figured out that temperature and RH can be displayed effectively on the same y-axis. So 60 degrees Fahrenheit and 60% relative humidity, with the date and time on the x-axis. And the optional date time slider on the bottom was a really popular setting, is a really popular setting. So at the top of the dashboard, you choose past day, past week, past month, and it adjusts the time displayed for the entire dashboard. But then under each graph with that slider, it makes it really easy to drill down into a specific day or time. Very user-friendly. Here's an example of a dashboard with a section with two loggers displaying the temperature and RH in the same graph. So when combining multiple loggers, it's best to use a standardized coloring system. I use red and orange for temperature and purple and blue for RH. The goal is to make it instantly clear whether it's a line for temperature or a line for humidity, since it's a shared y-axis. This is a graph. Lower portion here is the graph of the relative humidity of all the loggers in a large room. And so if you hover your mouse cursor over the line there, it can be used to display the time and readings on the right-hand side. So like this is useful to see the odd man out at a quick glance when you're looking at multiple loggers. In this case, again, when combining multiple loggers, it's best to use a standardized coloring system. And in this case, it's different shades between purple and blue. I really like that the dashboards are easily shared and can be viewed via computer browser or mobile browser. Usually I have it set up where cultivation is all in one dashboard, drying curing is in another dashboard. And one thing that I thought was pretty cool was, if you're using Microsoft Teams to communicate, and especially if you have multiple facilities, the dashboards can also be available in the More section of the Microsoft Teams chat on PC or mobile. And it makes it really easy for all team members and management to access the dashboard and get eyes on the environment. And it looks really good in the PC version. All right, so now that you have all this data, exporting for backup purposes and data comparison. Using the HOBO website, data can be easily customized and exported on a schedule in multiple formats. And so long-term collection of environmental data can provide room-specific, section-specific, seasonal insight. You can use things like an Excel pivot table to compare, or things like Power BI, and comparing section environmental data with other data sets to investigate trends and correlations. Things such as the environment's impact on transpiration during the growing process, or its effect on the dry room product dry down rate. and just overall insight into grams per square foot of production. Having that data provides the option for further optimization, research, and development. All right, let's get into configuring alarms and notifications. I can't stress this enough. Waking operation managers in the middle of the night needs to be reserved for true emergencies. If the alarm is to be effective, it needs to be accurate and not in the range of normal equipment, seasoned operational conditions, right? The thresholds that are too tight and trigger repeatedly will numb the user to the point of ignoring them, which reduces the effectiveness of responding to a real alarm situation. And depending on the facility, alarms may need to be adjusted seasonally. The alarm settings are really facility specific, and they need to be investigated over a period of time. The tighter you make the thresholds, both as a specific number and as the amount of time elapsed past that number, the more stable the facility would have to be to prevent a non-emergency alarm. So using the mobile HOBO Connect app, connect to the logger you want to adjust the alarms. The temperature high-low and relative humidity high-low thresholds need to be set up individually. What seemed to be the best data logging and alarm notification sweet spot was to sample every 6 minutes. So you get 10 samples per hour. And then when a sensor is past the threshold for either 30 minutes or 1 hour, the alarm is triggered and someone is notified. Again, you can go as tight as you want, but don't numb the user. Also, if pesticide or other foliar applications are practiced in flower, I do not recommend to turn on the high humidity alarm, as the RH can be over 90% in those cases. Alarm notifications are easy to create and to modify via the website. You can receive SMS alarm text message notifications to any custom user or users. Email alarm notifications are also available. But again, I need to stress, alarms need to be properly configured from testing before any users are added. All right, let's finish out with backup safety monitoring. Redundancy is key. Many environmental control systems are running off of very few sensors that control everything from heating, cooling, dehumidification, fan speed, lighting, you name it. A separate system allows for additional insight in controlling the plant's environment, as well as being a backup alarm system. I've seen a lot of thermostat and humidistat sensors. They're in less than ideal locations. Additional sensors allow for more detailed information to investigate if the existing sensors should be moved, or if any settings offsets may be necessary. Maybe you can't move your existing sensors. So maybe you need to offset that number by a few degrees in one way or the other to actually get the right temperature at canopy height. All right, product drying, curing, and storage. The dry room and cure room environments are critical, and they need alarms. In a dry room, by using 2 or more loggers in a 3D grid, microclimates can be easier to detect and mitigate. Humidity variation within the same room can be a sign of uneven or inadequate airflow. there was a facility with a long hallway type dry room, and they utilized supplemental fence. By experimenting with multiple loggers, we were able to determine that if the RH levels differed from one side to the other, it was an indication that the fans needed adjustment. So after every new batch was hung in the dry room, the processing manager would monitor the graph to see if any adjustments were needed. Again, loggers are mounted in a three-dimensional grid in locations that represent the flower's environment. We experimented with multiple loggers in the curing process and finished product storage, and we found flower product in containers can definitely be affected by the environment. Uncontrolled in more humid places, microbial risk increases, and in drier places, product quality is reduced. With so much work that went into growing it and processing it, it's not good for anyone to have increased microbial risk or reduced product quality. You know, you choose the environment you want and then set alarms to make sure that it stays. Additional monitoring options. This year, Onset came out with a new soil moisture data logger. You know, it's for use in both mineral soils and soilless media. You know, you have an option to view data in percent of field capacity. It's got a really durable sensor. You know, it's useful in cultivation to ensure proper dry down rates and verify the correct schedule and duration of fertigation events. And I'm excited to incorporate another level of plant optimization and safety monitoring into an already great dashboard using the MX Gateway. So today we talked about sensor placement, mounting, distribution. We talked about displaying data via dashboard. We talked about configuring alarms and notification, and we went through some of the backup and safety monitoring. Thank you all very much for coming. Thank you, Taryn, and I'm going to turn it back over to you.
All right, thank you, Nathan. That was excellent. And I am opening up the floor here to some questions. So if anyone has questions, please feel free to send them through the chat there, and I will read them off and we can have Nathan answer them for us. To get things started, the first question was about how many loggers you can connect to one gateway, and also kind of understanding the gateway range. So I will give you kind of the Onset standard answer for our HOBO MX Gateway. And then Nathan, if you don't mind kind of chiming in with your experience, that would be great. So essentially the MX Gateway can pick up to 100 loggers that are within an average of 100 feet line of sight for the range. But we have heard customers have different experiences with it. So Nathan, do you want to talk a little bit about your experience with using the Gateway?
Sure. Yeah, I know. I actually have managed to exceed that number. That number is a safe number, 100 feet. But you know, it really just depends on the facility. Depends on the facility design. But for small, medium facilities, I had no problems. Larger facility just depends, you know, on the design and the construction. But I was able to just go around with my phone, you know, pull up the loggers using the app and just move around the facility and find a location, in most cases, that I was able to reach every logger.
Excellent, great. Thank you so much. That's, you know, definitely customers have different experiences, so it's great to hear, you know, how they work in different environments. So I'm just gonna give it one more second here, see if we have any other questions rolling in. All right, how about, I'll kind of make this one a little bit more of a broad question, but Nathan, could you talk a little bit about, have you had any experiences specific to troubleshooting HVAC systems within different facilities? And do you have not only the plant managers, but actually the facilities managers using these devices?
Yes, the cannabis environment is a tough environment for equipment. We are running these HVAC systems hard, and they kind of tend to need maintenance over time. We've definitely had success catching those maintenance times early when it's starting to drift and not perform as adequately as we needed by using these loggers in locations near HVAC equipment. And yes, it really does help both the plant managers who are managing the plants, the cultivation managers, prevent plant stress, and it also helps facility managers, schedule that maintenance on time, if not technically earlier than you would have normally discovered that there was a problem.
Excellent, thank you. So this is definitely one I can't answer. So Nathan, I'm gonna throw it to you here. Do you recommend steering VPD higher as you approach harvest? And this is a question coming from Zach. Zach also has a question about, should the EC track with the WC? I'm not able to decipher that, so Nathan, I'm hoping you can. He has a few of them running, but it seems like they should be inverse, not parallel graphs. I'm wondering if my sensors are malfunctioning. I guess it's kind of a question for the HOBO team as well on that one.
Okay.
Water content.
Well,
thank you, Zach.
That's honestly, that's where the HOBO MX soil moisture and temperatures, is that what you're talking about? Or are you talking about the loggers? The loggers themselves, as far as VPD, sorry, let me back up. As far as VPD goes, it's how easy or how difficult it is for a plant to transpire in its environment, right? And so that VPD number can be different based, it can be the same number at different temperatures and different humidities. You can have the same number. But as far as increasing the VPD at the end of flower, have I experienced that? Not necessarily. I haven't seen any of the customers I've worked with necessarily try to manipulate the VPD at the end just at near harvest. And what was the other question? It was relating to water content?
Yes, so related to water content, should the EC track with the water content? So
the
EC
track with the water,
we're talking about electroconductivity, that particular new sensor doesn't monitor EC. The new MX soil moisture sensor only does temperature and soil moisture.
Yeah, no, that that really just depends. It depends on what your concentrations are. What are you feeding the plant? What are the volumes of water that you're putting through those pots, especially if you're using something like cocoa, because you very well could be building up salts. So that's kind of a separate issue, but yeah, it really just depends.
Excellent. So we had another question come up about, are there other solutions that HOBO provides for larger outdoor grow facilities? And I'll give a quick pitch here, but I'll try to stay off of my sales soapbox here. Yes, we also have a wireless mesh network. It's a system that is designed primarily for outdoor use, but it has been used in indoor facilities as well. Essentially, that is a system that works off of a 900 megahertz radio frequency, and you can connect up to 50 wireless sensors to one main cellular station that will then transmit all of your data back to the cloud. That is a very rugged and robust system, again, designed to be used outdoors. It's used in a lot of different agricultural environments. And again, I've seen it used in indoor facilities as well. So you feel free to reach out to the application team. They can certainly assist with designing a system around that for someone doing an outdoor grow. So let me just see here for another question. So Zach had one more follow-up here. Sounds like a constant VPD is your target then. Does that sound about right?
Honestly, it really depends. Again, in multiple stages of flower, you have transition. So you would want a stable VPD in that transition stage. You would want a stable VPD in your mid stage. You want a stable VPD in your flower stage. Stable conditions are the best. If you can actually achieve that, that is amazing and great. But yes, stable conditions for your plants. Plants are adaptable. They can really, it's a wide range for the maximum range. Optimum range is within that max range, but they can handle a lot, but they don't handle variability quite as well as they can just adapt to a constant VPD. Yeah.
And are there target VPDs or anything specific someone should be aiming for?
It also really depends on where you're at. Again, the max range of the plant, and when I say max, the outer edges, basically the plant stops growing, anywhere from like 60 degrees to 85 degrees is kind of that max range. And so, within that range, there's the optimum range, but that also depends on the type of strain and cultivar you're growing. So that kind of moves it around as well. So, one thing I like about these loggers and a lot about the dashboard is that it's a way for you to do kind of your own R&D to kind of discover and compare your grams per square foot versus what the environment was when those plants were growing.
Excellent. All right, fantastic. Well, I think that pretty much wraps up the majority of the questions here. I'll see if anybody else has anything specific. If you have questions specific to the HOBO product line, please feel free to reach out to our application team. They're available to assist you. If you have product already and you're struggling with it, we have a technical support team available as well. And if you have any other questions specific for Nathan, feel free to reach out to us. We can certainly reach out to him and get you the answers you're looking for. So I just want to once again, thank you so much, Nathan, for presenting today. This was excellent. Really appreciate your time, and thank everyone for joining us today. Really appreciate it.
Thank you, Taryn. Thank you, Onset. Thank you, everybody, for joining us. Appreciate it.
Awesome. Take care, everyone.